Well, hello everyone, and welcome back to Adrian's Digital Basement 2. On today's video, I'm taking a look at some NES stuff. I want to see about underclocking and overclocking the NES CPU, see if this is possible. On a recent main channel video, I took a look at this clone NES console. It's terrible, don't buy one of these, but it was inexpensive at least. When I ordered this thing, it came with Dendi, aka clone PAL CPU and PPU chip, and the appropriate PAL crystal oscillator. I've since converted this thing to run at NTSC frequencies, and I've swapped in genuine Rico parts for both the CPU and the PPU. Had to do a bunch of mods on the back to make this thing work in any kind of a reasonable way without a terrible picture and lots of interference. And what I did is I took the Dendi processor and PPU out of this thing, PPU being picture processing unit, and I put them inside this front loader. Now this front loader also has the PAL crystal oscillator, which is 26 something megahertz, and the original NTSC oscillator is the one that's in this board, and this is like 21 megahertz and change. While I was playing around with this clone and it was converted to NTSC just like you see here, I ended up taking the PAL or Dendi CPU and sticking it into this board. And I found that the board actually mostly worked, except for the fact that the slowdown in games was really, really bad. Well, and the sound didn't sound correct either. It was like the frequency was off. But what was more interesting is the graphics were working, in most games at least, they were working fine. But then there was some crazy slowdown. And the reason why is the CPU has a divider inside of it that takes the master clock oscillator and divides that down, and that becomes the CPU speed. So this is a screenshot from 240p test suite, and this shows the CPU speed on actual running console. It might have been actually this one here, 1.79 or 1.78 megahertz. And that clock speed comes from taking the master oscillator at 21.477272 megahertz and dividing that by 12. It happens inside the CPU, and that results in 1.789 megahertz. When Nintendo released the PAL Famicom, they decided to actually change the clock divider and the master clock. So the clock divider is now 16 and the master clock is 26.6 or so megahertz. That resulted in a CPU speed of 1.662 megahertz, so less than the NTSC consoles. But generally that's okay because of course we're only dealing with 50 frames per second versus 60. So there's actually a little bit more time for the code running inside the console to do all the calculations for the next frame because there's 10 less frames per second. Now where things kind of went off the rail, if you're talking about compatibility, is when you're doing that CPU cycle counting. And that's because each scan line that is drawn to screen, there's actually the same number of active scan lines between the NTSC console and the PAL versions. Well, I guess it's one less, 240 versus 239. But the number of CPU cycles per scan line, that is what has changed. It went from 113 and 2/3 to 106. So if you're doing cycle counting, it's going to completely break. So what I think the Taiwanese company UMC came up with is the Dendi PAL Famiclones. It's a clone of the NES, but it has timing much more like NTSC consoles, so games will be much more compatible. Of course, we're still running at 50 hertz because it is a PAL console, but all the things that matter for compatibility are very similar. So what they did is they kept the same PAL frequency, 26.6 megahertz, but they changed the clock divider to 15 versus 16, which resulted in a CPU clock speed at 1.77 megahertz, much closer to the frequency of the NTSC consoles. If we look at PPU dots per CPU cycle, it's 3 on the Dendi clones, just like on NTSC, and CPU cycles per scan line is also 113 and 2/3, just like NTSC. But the video output that's coming out of the chip is PAL. So it's composite video in PAL with PAL color and everything. It's just to the game code that's running, because all the timing and stuff is very much like NTSC. It's just running at 50 hertz versus 60. The game just runs slower, but it still runs correctly. And I think the compatibility is quite broad with the Dendi consoles, and that is very different than when you're using the PAL NESs. Now, I don't have an official NES PAL unit, like one of the ones with the Rico chips in them, so I don't really know what those are like, and I don't know what it's like to run NTSC software, like say stuff from the Japanese market, on those consoles. How much incompatibility is there? I'm not sure. But I do have some experience with the Dendi chipset now that I have that inside this console, and I played around with it, and it seems that pretty much all the NTSC software I tried on here works perfectly. The only problem is, of course, the game timing is controlled by the non-maskable interrupt that is fired during the vertical blanking interval, so that is directly tied to the refresh rate of your CRT, which happens to be 50 hertz on the Dendi systems versus 60 hertz on the NTSC console. So the games run slower. The sound is fine, like the frequency and the pitch and everything seems to be generally correct. Of course, the clone CPU, which generates the sound, there's a couple of the duty cycles on the square wave that are reversed. That's like a flaw in the design of the chip. It doesn't really affect anything other than the sound is just a bit different. But generally, yeah, the games seem to work without issue. They just run slower. Now, with all that out of the way, the topic of this video is, while I was playing around with this console, and obviously I have both the PPU and the CPU and the crystal oscillator socketed, the one thing that I noticed on here, and I thought was really hilarious, is I took out the CPU out of this, the NTSC CPU that has the divide by 12 divider to get the clock speed for the CPU, and I put the Dendi chip in here. That ended up running the CPU at like a 20% underclock. And while games were working, not all the games, because games that are obviously counting cycles and stuff aren't going to work, but games that don't do that, well, they had massive lag. So what I want to do today is I want to repeat that experiment. I want to put the Dendi CPU back in here now that the thing has fixed up video circuitry and stuff like that. So this should produce a much better image, so we can see what kind of side effects we get with the slowdown and stuff like that, and which games work and what don't work. But what I also want to try is I want to try putting the NTSC chip into the PAL console. And I can use the calculator to figure out what the clock speeds are going to be with these two scenarios. So first off, if we put the Dendi CPU into the NTSC console, that is our clock frequency. And instead of dividing by 12, which will give us the 1.78 megahertz, it's dividing by 15, which means our CPU is running at 1.43 megahertz. Now you might think the fact that the CPU is running at the wrong clock speed would make the system not work at all. But no, it does work. It just has a lot of slowdown. So talking to Mark at the Retro Channel, that's where I got the idea of maybe taking the PAL console with the PAL frequency oscillator, the master clock of 26.6 megahertz, and putting the NTSC CPU into it, which would divide it by 12, which would run the CPU at 2.2168 megahertz. Now, the funny thing is, I want to see if like this A works, and then B, theoretically, if we go to any game that has slowdown, well, we have a lot more clock speed available to us, and maybe there wouldn't be any slowdown. Now, of course, one big issue here is that already the PAL version of the console, well, the Dendi version of the console, has less slowdown, and that's because the 1.77 megahertz CPU has more time to work on each frame, because of course there's only 50 frames per second versus 60. And it's right here on this chart that shows us this extra time that's available to the CPU on the Dendi console. So this is the Dendi column. And see this post-render blanking? This is the amount of time between the end of the frame being drawn by the actual PPU. That's where the PPU is accessing the SRAM, and you're not allowed to really write to it. And then the non-maskable interrupt fires, which will trigger the routine in the software to actually update the OAM, which is inside the PPU, and of course the SRAM for like the video display and stuff like that. That all happens in the blanking interval. And on NTSC consoles, you have exactly 20 scan lines to do that. And that amount of CPU cycles is 2273. Now on the OEM PAL console, the non-maskable blanking is way longer because, of course, the active picture area is still around 240 lines, but PAL has more lines. So that means you have more CPU time once non-maskable interrupt fires to actually update the PPU and whatnot. That happens in this 70 scan lines versus the 20 on NTSC. Problem is, the 20 scan lines is generally enough time. If you watch Displaced Gamers, you'll know that most games, that is not a problem, and that's enough time to actually update the PPU. The issue is, while the frame is being drawn to screen by PPU, that's when the CPU is busy rendering the next game frame, calculating the sprites and all that kind of stuff that's happening in the background. Well, what happens is, while the PPU is drawing the frame, if the CPU runs out of time doing all those calculations, non-maskable interrupt is just boom, it's going to fire. And if the CPU is not ready, like it hasn't finished generating the next frame, what happens is it just repeats the last frame, which that's where the slowdown happens. And with an NTSC or the OEM PAL system, we only have 240 scan lines plus this one extra scan line to generate the next frame, and then the non-maskable interrupt hits. Well, here's what the problem was with the OEM system is that Nintendo added all this extra time into the blanking interval after non-maskable interrupt happens, which is generally just used to copy the frame into the PPU. That's not where the time is needed. The time is actually needed in the active area of the image before non-maskable interrupt fires. That's where the CPU is doing those calculations. And that's where the Dendi system works a lot better than the OEM one, is because at the end of the active image area before non-maskable interrupt fires, Well, that's where 51 extra scan lines were added. And that just purely translates to additional computational time for the CPU to finish calculating all the stuff that's happening in the game before NMI fires, and then all the data gets copied into the PPU, and that, updates the screen on the next frame. So because Dendi already has 51 additional scan lines, which if you calculate the amount of cycles per scan line, I mean, that's a good number of extra CPU cycles, slowdown is already going to be a lot more reduced. And when I say slowdown, of course, the game is going to be running slower because it's tied to the 50 hertz versus 60 hertz. So that's the overall flow of the game is going to be slower. But when we talk about NES slowdown, we're talking about when you're playing and the game is like stuttering and, really slows down. And that happens when the CPU runs out of time to do those calculations. That's what I'm talking about with slowdown, not the 50 hertz versus 60 hertz. Well, already the Dendi system is going to have a lot less slowdown because of all this extra time. And what I wanted to do by swapping the CPUs around and using the NTSC CPU in the Dendi system is see if it works. And I mean, that should theoretically totally eliminate all the slowdown. And that's simply because the CPU is going to be running so much faster. What do we calculate at 2.21 megahertz? That's a substantial overclock. And that means that I think all slowdown totally would be eliminated. Now, the interesting thing is I'm trying to think of like a good place where there's always slowdown. And I can think right away to Super Mario Brothers USA, Super Mario Brothers 2. There's this one thing really early on in the game when you like throw a piece and it slows down so badly on NTSC. So I guess the first thing I need to do is fire up the Dendi version of the console. Well, I guess fire up the NTSC console, see if I can figure out exactly where that slowdown is so I can replicate it. Then fire up the stock Dendi console and then try to experience that slowdown to see if that slowdown is even there or not. And then do some CPU swapperoo. So we could try putting the Dendi CPU into the NTSC console. The slowdown should be much worse. And then vice versa. If the slowdown is happening on the Dendi console still, then I could take the NTSC chip. And if this works at 2.21 megahertz, then that slowdown should be gone. And the funny thing is, the reason why I'm even talking about that is if you can just overclock the system this way, and some games will work, then there's nothing to say we couldn't make a new CPU theoretically, like with an FPGA or something, that is using a different divider that actually overclocks, and you could pop that into your NES and get rid of slowdown, even with an NTSC one. The non-maskable interrupt, which is what's driving the refresh of the screen, that's coming from the PPU. So if you have a 60 hertz PPU and the correct clock frequency for that, like the 21 megahertz master clock, then the graphics are going to work properly at the correct rate. And it's just the CPU's divider inside that controls how much processing horsepower the CPU has. Now, it goes without saying that things that count cycles, CPU cycles, those are always going to break if you run those faster. So you'd have to purposely be able to like selectively not run those games in those faster modes. Or maybe we could even have like a dynamic speed thing so that certain things are sped up. Incidentally, I just want to talk a little bit more about this here, this post-render blanking. If you ever use a NES emulator and you've noticed it has a mode that tries to eliminate slowdown, like it will make games run better, what they do is they extend this post-render blanking time way, way out. Like they add hundreds of extra lines there. That just gives the CPU a lot more time before it needs to actually render to the image. And because, of course, on the emulator, you can, manipulate anything dynamically like that. That's what we'd really need to replicate in hardware to be able to have an NES that hopes to eliminate slowdown. Anyhow, let's get this stuff hooked up here. And first, I'm going to try to find that slowdown. I think Super Mario Brothers 2, like I said, on here. And then I will move to the Dendi console. We'll see if we can replicate it. And then I'll start swapping chips around. Yes. Now, one thing I have to say is that it's really weird. Is for some reason, this clone EverDrive does not work in my Dendi console. It did work in this thing when it had the Dendi chipset and the crystal in there. And all I did was swap the CPU, PPU, and the crystal over to this, and this no longer works. It just is all corrupted when it starts up. Still works fine in this console using the NTSC stuff, so I don't really get what's going on there. I suppose what I could do is once I have this thing open, I could take the crystal out of here and I could stick it back into this, so we could try running the EverDrive. Otherwise, I'm stuck with running games that are on this 154-in-1 or the original games, and I do have Super Mario Brothers 2 on this. By the way, I just want to mention a few other things about this crappy Famiclone here, is that the interference that you see on the screen here when I use the RetroTink, it's way less visible when I hook this up to an actual CRT, because I usually use this stuff hooked up to a CRT, not with this scan converter. And all of these lines that are happening here, they're just not visible. So I don't really know why that is, but obviously this thing, the RetroTink that is, just makes it much more susceptible to those interference lines. Okay, so the slowdown that I always saw with this was specifically, wow, it's so hard to play through OBS because it's so laggy. Like what I'm looking at is so laggy. The slowdown I always saw was here. If I throw this shy guy, throw him away. Didn't do it that time. Yeah, sometimes when you throw him, there is a ton of lag right in that area. So let's see if it does it right here again. I mean, that's kind of concerning in a way that there was no lag there, because that means that we're only on the edge of the slowdown or the lag. Like there, I just had a little bit of lag there, but that's certainly not a repeatable amount. All right, I've slowed down the footage and I'm doing a voiceover here because I've noticed something about this crappy Famicom. We can actually see when the lag is about to happen. Notice those diagonal lines? Now I've changed the image to enhance them a little bit. That's the tight loop that the CPU goes into while it's waiting for the non-maskable interrupt so it can update the next frame. The NES CPU will basically process what needs to happen for the next frame, is doing that while the PPU is drawing the frame, and then once the non-maskable interrupt happens, it then copies what it has done. It copies its work into the PPU, and then that will be drawn as the next frame. It's always rendering one frame ahead. Well, you see how those diagonal lines kind of move around? Sometimes they're higher up and sometimes they're lower down. That's the actual CPU processing the work. And all that static at the top are all the random instructions that are happening. And because this board is so badly shielded, that leaks through into the PPU. We're actually visualizing the CPU working. So when those diagonal lines get all the way down to the very bottom of the screen and go off the bottom, then we're gonna have lag. And here it's gonna happen right there. And notice how now we're having alternating frames where all you're seeing is diagonal lines, and then it looks like they're kind of alternating there and gone. Well, that's happening because when lag happens, the CPU only needed a little extra time to calculate the next frame, but because it didn't make it in time, it uses the next frame or the very start of the next frame just to finish up its calculations, and then it goes into a tight loop waiting for NMI to fire. So it just needed slightly more scan lines than just one frame. And then once it does that calculation, it just sits there waiting. So what you'll see is you'll see an alternating frame where there's no diagonal lines, and then you'll have one where it's almost all diagonal lines, and it will go back and forth while the lag is happening, and then it goes back into the normal sequence. And you can see the lag is jumping all around as I move around the level, and we can visualize the lag. I can't believe this. I didn't realize that's what's going on with this crappy Famicom clone. But yeah, that's what that static is. That is the CPU executing code, and then those diagonal lines are without a doubt the tight loop that it's in while it waits for NMI. And you can, on emulators, you can turn on a feature where you can see those tight loops visualized on top of the image, and they look just like that. Diagonal lines. When not a lot is happening on the screen, you can see the diagonal lines go up near the top because the computation for the next frame is very minimal. But then when there's a lot going on, it's very busy, you'll see those lines move down, and eventually then the lag happens. Wow, I'm amazed. I suppose what I should do is let's just try it on the Dendi console. I'll just play a little bit on that same first level, and I'll see if I can experience any of that lag. It's like slow motion. Now, I've been unable to get this to slow down at all. So my assumption is that's happening because we have so many extra scan lines in that post-blanking period there. That allows this thing to just kind of compute the rest of the frame without any slowdown. Okay, well, I think this is just going to end up being a test to see if this is even a viable concept. So first things first, I'm going to open up the Dendi console here so we can start swapping parts around. And I've lost my screwdriver. Here it is. Yeah, look at this. If you're inside Washington State, you call this phone number. That's a Seattle phone number. Look, it's telling me I need to use a specific power adapter only. You know, I've just been using a random 9 volts DC power supply. And it does work fine. You don't have to worry about that. Not with these, at least. These have a bridge rectifier on them, so the polarity does not matter. That is not the case on some of the consoles, though. I think the Famicom needs center negative. Otherwise, it will have issues. Same with the Super NES, or maybe just the Super Famicom. I can't remember. Alrighty, so looking at this console, there is our PAL crystal oscillator. It's in a little socket so I can take it out easily. And of course our CPU and our PPU. So the crystal and the PPU always have to stay together. You cannot swap those around. But what you can do, at least I could put this CPU that has the, what is this, divided by 15? That can go into the NTSC console, and this CPU has the divide by 12. So I really want to put this in here and see if that works. And I know this works in there generally, and we're going to try that first because I want to see that really bad slowdown that you get with this. So first off, let's test this out. We've done this before. I know this is going to work for sure. And the thing is, I didn't have the video fixed when I ran this last time. So therefore, there were all sorts of weird video issues that we will not experience now. It seems like games get glitchy, but generally the video is stable, unlike before. Incidentally, I think I mentioned this in the video on this dumb design, the voltage regulation runs all the time. The power switch is after that. That's just silly. Why wouldn't you just switch the 9 volts? I don't know. Oh, something weird going on with this. What's going on? It's weird. Power LED's not coming on. Why? What happened here? Did I damage something? Let's take that out again. No? Did I just break this thing? Why isn't the power light on? Okay, we're getting 8.1 volts, and how about out of the 5 volt circuit, 5 point whatever. So that's working, but when I turn this on, 1 volts? What happened here? So like I said, the regulation is running all the time, and it goes through this inductor, that cap, that small cap, and then to the power switch, and then from the power switch, it goes to the rest of everything else. Well, we were just playing on this thing, and it was fine. So what just happened here? I'm going to remove this. Doesn't do anything anyways. Yeah, from ground to 5 volts is now 107 ohms. Yeah, so that's ground, and this is 5 volts, and we have 107 ohms? Well, that doesn't make sense. Let's remove this PPU here. Hope I didn't damage something here somehow. How about now? Yeah, it's okay, 110 ohms, barely different. Okay, the only thing I could think of here is I do have these screws in here. What if this is shorting it out somehow? Because these aren't really supposed to be here. Okay, how about now? Nope. This is weird. So I'm just going to put 5 volts directly into this from my bench power supply, and let's see what happens. Yeah, it just immediately goes into current limiting. So we definitely have a short on here. Now, the funny thing is you're looking at this and you're like, oh, it's probably right here, right? But it's not, because if I plug the power supply back in, then we're actually going to have 5 volts on the power supply. There it is, 5 volts. And that's coming through all this. So see, there's 5 volts right there. There's 5 volts right there. So it's not shorting to ground because that stuff is currently energized. The short is after the power switch. I bet you I just blast 5 volts into this thing and just see what gets hot. I'm going to do that because I just don't care right now. I just want this thing to work properly. So I'm going to fire up the Top Don TC04. Okay, I'm going to feed 500 milliamps into this thing. And that's happening right now. Yep. The hot part is right there. It's one of these two components right here. Oh, piece of crap. I swear everything about this thing sucks. Okay, so we'll do this and hopefully I can do it where you can see what gets hot. So there it is. There's our shorts right there. It's clear as day, isn't it? Turn it on. Super hot. I'm going to lower the current down to something like 100 milliamps. Okay, so it's not getting so hot. I mean, it's still hot. Let's see if I can figure it out. It's definitely that part right there, isn't it? It's a little ceramic cap. That one. Now, the weird thing is with this cap, because I don't know if it's not like a dead short. I don't know. Boy, this board sucks. It sucks so bad. Okay, that part's been removed. It's right there. I'm going to turn on the bench power supply. It's still plugged into the bottom. Yep, our short's gone. See the power LED come on? There you go. So that piece of junk, ceramic, tiny little cap, whatever this is doing, is bypass probably, freaking shorted. 130 ohms. I mean, that's a bad ceramic cap. That's the failure mode of these stupid little things. All right, there we go. I just bodged that 104. I just had sitting on my desk onto there. That should be good enough. And then I'm putting this back on, but I'm putting on these little washer things here. It's a fiber washer, just so that screw is not directly on top of traces. The other one actually has enough space, this one here, so it's over just sort of that ground pad. This one over here, though, it's not quite so good. And I did put screws here in the cartridge connector. That way, when I push down on this, it doesn't bend the board, because that's what it was originally doing. Okay, so back to what we were doing. So the CPU, this is the bottom part. This is the PPU on the top socket. I should probably just write that on there. This should run now. Just make sure we get the power LED. We do. Let's plug the audio and the video back in, and we can game with slowdown. Thank you, TopDon TC004. You certainly made it very quick and easy to find that particular fault. Very happy to have this thing. Okay, here we are, up and running. Let's see some serious slowdown. Whoops. Video is going to work a lot better now that this has, you know, the 75 ohm termination resistor. Yeah, looks good. But the speed, you know, the game is playing at 60 frames per second. It's just the tones are wrong. That's, of course, because the CPU is what's generating those tones, and it's using its clock to do that. So if it works the other way, where the NTSC CPU works in the Dendi, then all the frequencies are going to be higher. But we should have way worse slowdown now. Okay, so far so good. No slowdown. Oh, there was slowdown right there already. It was slowing down already. Oh, even that slowed down. So when the health bar at the top left, oh, it's like slowing down like crazy already. Whenever it flickers, that's a really good indicator that we're getting some slowdown. I love it. I love it. I'm gonna get that heart. Oh yeah, it's slowing down left and right. Well, we knew this was going to slow it down, right? Because of course we have a lot less clock speed, but it's so funny how the game is just, whoa, like I can barely move. Do you see how it was like molasses right there? So it's just the CPU is running out of time. Darn it. Like I'm running right now, but you see how slow Mario's going? Okay, so Super Mario Brothers 2, super laggy. I think even Super Mario Brothers 1 was really laggy, and there were some issues at the top because during the scrolling, I think there's some glitching. Let's see, so far so good. No, it's laggy, right? Already it's laggy. That's amazing. See the hearts at the top there kind of glitching out? So I think it's scanline counting to transition between the HUD there and the gameplay or the game field or whatever you want to call it. So yeah, it's laggy already, even this game. Oh, laggy, laggy, laggy. Not so bad. Not as bad as Super Mario Brothers 2, though. Now, I was playing on the EverDrive last time I tried this, I think. Oh yeah, so this is all super glitchy, this MMC3 game. Look how it says 1988, and then there's a 9 below it. What does it actually say on the North American release of this game? Does it say 1989 or does it say 1988? Oh yeah, it's flickery, flashy. Sorry about that. If you don't like flashing, you should probably look away. Oh, it's not too bad. Oh, it slows down so much right there. Look at that. I can barely move Mario. I'm running there the whole time, and he's just He was just kind of sluggish. So now we're back to 60 frames per second up here, no problem. Oh, but then it slowed way down. Oops, I missed that. So MMC3 games work a lot better than I would have thought. Although, did you see the line between the playfield and the HUD at the bottom? How it was kind of moving around? Even on a regular clocked one, it still has a bit of glitch over on the side, but the glitch is 2 scan lines now. Oh, slow motion, slow motion. It's so slow. Oh. I'm wondering if does the counter slow down when it gets so laggy? Interesting. Didn't notice. I'm not sure the time. I'm trying to watch the time. It doesn't look like it slows down, or does it? Oh, look how like it's messed up at the bottom there, because obviously it's cycle counting as well, and you know, the cycles are different now. I never can get this. Okay, so Mega Man games are really laggy. Oh, you know what I think is on this cartridge that's always incredibly laggy is Contra Force. Yeah, this game is like lag fest even on the best of times. Maybe on the Dendi console with its original CPU, it would actually be not laggy. Let's see here. But here it's going to be incredible lag. Oh yeah. It's a me. I mean, this game's unplayable as it is. So, but it's just, it feels like I'm playing literally in molasses right now. Oh, this is hilarious. Oh God, this is so funny. Oh, what am I supposed to do here? I don't even remember. Oh yeah, shoot through this, and I think I'm gonna die in a second. It's total molasses gameplay. I love how while you're spinning, you can still shoot. Like, that doesn't even make sense. This game, so much about this game doesn't make sense. Oh yeah, that's... Okay, anyways, that's funny. Okay, we're trying Castlevania here. So far, so good. 0 issues at all. Even with 20% less... Oh, whoa. Okay, well, clearly we had a little bit of an issue there. Oh, it's Flicker Mania. Oh boy, and it's super slow as well. Like, the image was literally rolling there, but not the sprites. This is just a fascinating thing. So there are moments when everything feels normal, except for the music, but then it very quickly turns into molasses mode. Yeah, it's very slow, even right here. With our jumping friends, and like... Oh dear. Okay, how about Kirby's Adventure? I don't know if this is even gonna load. Okay. Okay. Bit of corruption there. Okay, yeah. Not working so great. If any game is going to use cycle counting and all the tricks, is going to be this. Okay, so this is not really usable. All right, well, I have to say, things seem to be working really well. Last time I tried this, when the video wasn't working correctly, we had a lot of issues on the retro tank. Now you can see the video is pretty stable and most games are playing perfectly fine. I am curious if we can try using the EverDrive. I don't think it's going to work, but give that a try anyways, see what happens. Yeah, corruption. So this is just like last time. it seems to be very sensitive to the CPU cycle timing, because if I put back in the original CPU, without a doubt, this will work on here. It just doesn't work. Doesn't work on here when there's not enough CPU time. It's almost like I can see that there's text there, but I hit start and it doesn't actually work. Okay, I think that was enough experimentation with this combination. Now it's time to, well, try that one out. And by this one, I'm talking about the NTSC CPU inside the Dendi console. So this is going to be our overclock, 2 point whatever megahertz, what this thing is going to run at. I'm not totally convinced that this is actually going to work. That might be too much of an overclock for this particular CPU. All right, here we go. Do you think this is going to work at all or what? The game is running. CPU's overclocked. Oh yeah. Well, let's go try Contraforce, because we know that's ultra laggy, but I'm not sure I ever got anything to lag on the Dendi as it was, you know, without the CPU overclock that we have right now. Okay, here we go. I mean, I don't know. Doesn't feel laggy. No, I don't feel any lag at all. I would certainly have a sprite flicker, but I don't know about lag. Whoops. But again, it might not have lagged anyways, even with the Dendi, you know, the stock Dendi system, just because of all the extra scan lines that we have available to us. Now we have extra CPU speed and extra scan lines. How are you supposed to get this guy? I'm noticing here when I hit the start button, there's some like garbage on screen there. That must not be right. I don't really know this game that well, so I couldn't tell you what's normal for it. This game does support 2-player mode simultaneous, and I think that produces a ton more lag as well. But so far, this is not laggy. So I don't know what to say. But we are running an overclocked CPU. Without a doubt, we are running the CPU. The NES CPU is running at like 2 point something megahertz right now. So we have way more CPU power than we normally have for it to finish rendering these frames. Well, definitely lag free. Let's see the compatibility with other software though, like Super Mario Bros. 3, MMC3. Let's see how that behaves with our overclocked CPU in Dendi mode. Okay, the slowness of the music. This is totally due to the 50 hertz. I mean, there's no issues here. Literally, if someone had just made a CPU with a divider that wasn't divided by 12 for NTSC, maybe divided by 10, and then we would have less lag. And, you know, maybe some incompatibility, but you'd be able to play NTSC with more speed and less lag. I am shocked at this, honestly. Yeah, this really works fine, other than the fact that it feels like I'm in slow motion because we're at 50 hertz. But wow, overclocking the NES CPU. Who would have thought that this is possible? I honestly never, I never thought it was possible. Now we cannot change the master clock. It completely is required for all the video generation and the PPU. The PPU would have to be redesigned for us to change the clock. So that unfortunately is not a way for us to try to overclock the CPU. It would have to be a CPU that has a different multiplier inside. And because the NTSC ones have that 12 multiplier, we would need one with even less of a multiplier to speed up the console, or the CPU that is, and overclock it like we're doing here. Okay, so let's try using the EverDrive. I don't think it's going to work. No, I don't know. It's just doing this, which is weird. It's like a bad cartridge counter, but I'd never have the other thing ever glitch out. None of this is screwed together, so I suppose that could be part of the issue. I really want to run 240p test suite, but I don't have that in a standalone cartridge for me to run. I wonder if you can just run that. Like, does it require a mapper or anything? Because if it doesn't, then I could theoretically I don't know, take like a junk cartridge. Unfortunately, I had some junk cartridges, but I gave them away. But they would have been perfect to try to replace the ROMs on them with the 240p test suite. But yeah, clearly this does not work. But yeah, this multi-cart boots right up immediately. Music is all out of tune. All out of tune. This jumping sound. Listen, listen. Oh, that's funny. I mean, there would have been lag there for sure, and there was no lag. Lag free, everyone. Lag free. The DMC channel works flawlessly, I must say. Zero issues there. Okay, I don't remember if we tried Kirby's on this console with the overclock CPU. Let's see if this works a bit better. Yes, it certainly does. So it didn't appreciate having less clock or CPU cycles available, but it seems to be totally fine with an overclocked CPU, which tells us that we could totally, well, I mean, I'd say it's trivial, but we could have an overclocked CPU on this and it should work. Wow, that would be so freaking cool, wouldn't it? Yeah, this game is working fine. Haven't seen a single issue other than the fact we're running too slow at 50 hertz, but otherwise totally, totally fine. That's amazing. All right, well, this video was just really much ado about nothing. Essentially, I just wanted to show that you can run an overclocked CPU in an NES and it works. Of course, you have to run it in a Dendi console like this, and therefore the games run really slowly, so you're not getting the advantage of having that extra CPU horsepower to eliminate slowdown, because the game already is running really slow, and I think even with the stock clock speed, you're really not going to have much slowdown anyways. It would be really curious if someone who's really good at Contraforce, which is a horribly slow, laggy game, could try this same thing with two players, someone who's good at it, and play through a little bit and see if it really does eliminate the lag. Or ideally, you would compare the original Dendi stock CPU speed, 1.77 megahertz, against this 2 point whatever megahertz we're running at now, and see if it really does eliminate the slowdown. Because we know going the other way, by putting the Dendi CPU into the NES console, definitely creates a whole lot of slowdown where there isn't any, because obviously it's running out of time to generate the frame before the non-maskable interrupt happens. This is fascinating stuff, and it really shows, especially going the direction that we went here with the overclock, that if someone were able to make an FPGA version of the CPU that was cycle accurate, but used a multiplier that wasn't 12, maybe 10 or 11, or maybe adjustable, then we could really have real hardware that was not laggy running in NTSC at 60 hertz. How cool would that be? I mean, the games really all seem to be working without issue with the overclocked CPU, as opposed to the other way around, where we had all sorts of weird glitching going on. So I think we could potentially have even a CPU running at 20 megahertz, and a lot of games would work. And obviously we'd have zero lag at that point, because everything's expecting 1.78 megahertz and trying to get everything done in time. But even the slowest of the slow games theoretically could have all of the lag eliminated. How neat is that? All right, I was just copying the footage over because I was done with the video, and I decided before putting this thing all back together in its stock configuration, I turned it on with the EverDrive and it fired up. So we're running the Dendi PPU, but I'm running the NTSC CPU, so we are overclocked, and my EverDrive is working. So it's almost like this thing does have a, I don't know, some bad connection that the EverDrive doesn't like, and I just put it back in and now it's fine. One thing I will mention is that normally this thing will say NTSC, PAL, or Dendi down in the bottom right corner. I can't point to it, but next to the select. It doesn't say anything right now because I don't think it knows what's going on. Yes, 2.19 megahertz. We are definitely overclocked. That is why there was just going to be very little lag, because there's so much extra processing power available on this Dendi unit than is available on the standard NTSC one. That is so cool to see that, to actually see that working here. Now I should be able to reset the console if I don't touch the EverDrive. And I do have a demo on here we can take a look at. The demo I wanted to run was mapperless. It's right here. This is the one that I think is going to have, unsupported hardware. It's able to detect that it can't run on this. Yeah, this does all cycle counting because it doesn't use any mapper at all. Therefore, all of its graphical tricks require perfect cycle accurate CPU speed. That's funny. Now, one game that was messed up with the underclock was Bionic Commando. And I wanted to see if this thing runs perfectly with the overclock. Probably it will. I think this already worked perfectly on the Dendi console, just slow, obviously, and it's still going to be slow. But it was very glitchy on the underclock, and then also very, very laggy. Okay, so yeah, detected 0 slowdown with Bionic Commando. 0. Totally works perfectly, other than 50 hertz, but yeah. It may not have slowed down anyways with the Dendi, but it certainly is working perfectly. All right, well, it's time for a new outro. So I was able to prove, without a shadow of a doubt, that this thing is running an overclock CPU at 2.29 megahertz. So it would be absolutely amazing if somehow someone were able to create an FPGA CPU that could go in here. It had a good 6502 core that whatever replicated cycle exact how the NES core works, but allowed us to adjust the multiplier. I also had another idea that maybe I could just run the CPU asynchronously, because the clock circuit on here, just that 21 megahertz, just goes and splits off. One goes to the PPU and one goes to the CPU. Well, maybe we can just run the CPU at any arbitrary clock speed. It doesn't seem like it's that important that they are exactly linked. Now, of course, this is a division that's happening right now. So even though the CPU is overclocked right now, it's still running at a multiple of the master clock. And it's possible if I just disconnect those and arbitrarily clock the CPU higher or lower, that could introduce problems, but maybe it won't. It will always affect the sound. If you change the clock speed of the CPU, it will change the pitch. There's no way around that unless we have an FPGA CPU that is able to generate the sound stuff based on the master clock, so it's perfectly in tune, but then the actual execution of the CPU core could be separate and independent. That would be possible with an FPU. Also, if someone has a fab, they could make a CPU like UMC did here with a different multiplier. That would totally be possible. And then, of course, it could still generate the sound off the master clock using the divider, like the divided by 12 for NTSC. And then the CPU could run at a different speed. But obviously, that's not going to happen. Now, I don't think anything I've done here is groundbreaking. I am sure all of these scenarios of trying these different CPUs has been tested before. I just didn't know about it. I had no idea you could underclock or overclock the CPU on the NES and it would actually work. I just assumed it would not work. If you tried this, the thing wouldn't work properly. But obviously, as we can see, running 240p test suite, overclocking the CPU makes the NES feel like it has more scan lines available to it. Therefore, the programs have the ability to do more in that amount of work, that time in between the non-maskable interrupts, so you eliminate lag. How cool is that? Too bad I can't get the overclock CPU working right now on the NTSC console, because of course that's what I really want. I want the games to run, at the correct frame rate, just with more time. It was still a fun thing to try and experiment on though, and yeah, I'm kind of glad I kind of went back and revisited this, because all I knew is I could underclock, because we did that in the last video on this thing. And well, there we go. We can overclock as well. How freaking neat. So I hope you enjoyed me just sort of fooling around here, and maybe this will give people some ideas on, well, smart people who are way smarter than me who can come up with the FPGA core that could allow us to eliminate the slowdown on real hardware. Like, that's the goal here. You can already do it on emulators. Let's figure out a way to do that on hardware. And that reminds me, I remember reading something about some project in Japan that was exactly that, but it was extremely limited, it was not open source, and it never made its way out of like some web pages. But apparently it was some kind of CPU replacement for the NTSC NESs that would, I don't know, run the CPU core faster, I guess, just like we did here, and eliminate lag. So there we go. If you like this, thumbs up. If you didn't, you know what to do. Thanks to my supporters, subscribers, all those people. Subscribe if you haven't already, and the usual YouTube junk. I guess that's going to be that. So stay healthy, stay safe, and I will see you next time. Bye.